This is the Chainless Challenge Group. My name is Matt Hinesley.
I'm Matt Eschenbrenner.
I'm Ryan Bradway.
Parker Hannifin puts on this Chainless Challenge competition. This is a competition in order to build and design a bicycle that does not use chains. So you can either use hydraulics or pneumatics. We decided to go with hydraulics. They have 4 different challenges that we partake in at the competition. They score us on those and score us on cost analysis and presentation of our material. So I'll have Matt talk a little bit about the hydraulics of our bike.
So for our design, we really started from the ground up. We knew that these were the races that had to happen, so we had certain requirements, such as speed, gear ratios, and things like that. So we optimized our system to do well and on all of those. And here's the schematics for the different hydraulic modes. We had a pedaling mode, which is just like on your normal bike. A charging mode where you can charge the accumulators. A boost where you hit a button and the bike just goes. A regeneration where you can restore power, which is a green initiative, which is going on a lot in the world today. Also, we were able to build everything from the ground up. So all the design was done on the computer, and all the results from the competition ended up being similar to the computer. So it really shows that in industry, you will design first and then build. You won't just jump into building. And this was a good experience to show that the full process of starting with a CAD model on the computer and ending with a bike that we can sit down and pedal in. And then also, for our cost analysis too, we had to make sure that it didn't cost too much and that it was feasible to be purchased. So a lot of the options you see, like a regeneration pump, we have a screen that controls everything, those were all different options you could put on. So it wasn't essentially just build the most complex bike as possible, but you had to think about options you could put on and take off to make it, you have your base model, but also your logo dream model as well. Next, Ryan's going to talk about the gears and frame.
So once we had all this optimization models, everything calculated for us, we had to go about making what we made on the computer into a physical model. So what we ended up with is, this bike that we chosen. It was a bike we purchased, and we had to add on to that bike by making the gear system so we can optimally run our pumps and our motors. And we have the front gearbox, which operates our pump, and then we have our rear gearbox, which houses the motor and our regeneration pump. So we went through the process of designing the gear trains, making sure that we wouldn't shear teeth, making sure that the structure was strong enough. And for regeneration, we made sure that that would operate optimally with all of our Amazon models and all the other components. We also manufactured all of these frame structures. We have a partner who did abrasive water jet cutting for us, which is a pretty cool technology that we get to experience.
In the actual competition, we ended up placing second overall. And this competition was different than others. In some competitions, you get to actually see your results and see what happened, but ours, we get to build something from the ground up and then test it. As you came in second place, it works. The computer said it would work, but in reality, it worked as well. And next, he's going to talk about the alternative design solution that we thought of.
So unfortunately, we don't have the competition bike to show you guys, but we do have an alternative design that we came up with that was using a lot less parts and more cost-effective that we could actually maybe mass produce and send out to the public. So right over here is our alternative design. It's pretty simple. It uses 2 hydraulic cylinders right here. It doesn't have a rotary motion for pedals, but it does have an up and down motion, which extends and retracts the front cylinder, which does the opposite in the back cylinder, and rotates this gear back here, which then rotates the wheel.